meter rod of mass 2 kg is pivoted at point P as shown in figure 2 above. A load of mass 6 kg is suspended at one end and another load of mass M is suspended at Q. If the system is in equilibrium, determine the value of M. From figure 2 here, the rod here is in equilibrium, okay, and the rod here also uniform rod. So I mean that weight for rod is at the center of the rod. Okay, let's say here center of the rod. So direction weight for rod here is straight downward. Okay, let's say we label it with weight 1. Okay, none for mass suspended here at point Q here. So direction weight here straight downward. So we can label it, let's say we label it with W2. And another weight here for mass 6 kg here. So direction weight is straight downward. So we can label it with W3. So all the forces here, W1, W2 and W3 here downward. So it means that another force to balance the system must be outward. So where was this force? So the force here is at point P. So direction force at point P here is straight up. So you can label it, let's say, FP. So for case here, we can use torque, okay, to determine the value of M. When the system is in equilibrium, so it means that net torque must equal to 0. So for axis rotation here, we can choose point P here. Okay, point P here for axis rotation. So net torque at point P equals to 0. So it means that torque clockwise must equal to torque anti-clockwise. Okay, we know that torque is a vector. So torque equals to R cross F. So magnitude for torque equals to RF sine theta. So theta here is angle between vector R and vector F. Okay, so we check our system here. So acceleration at point P. Okay, so here is R1 to W1. So direction R1 from axis rotation to apply force W1 here. So we can label it with R1. And angle between R1 and weight 1 here is 90 degree. So what is the value for R1 here? Okay, we know that weight here at the center. So it means that here is 50 cm. So from point P to weight 1 here must be 30 cm. Okay, from R1, from axis rotation here, okay, so torque here rotate clockwise from R1 to weight 1 here. And then for another force here, weight 2. So here is rotation to apply force weight 2 here. So here is R2. Okay, here is weight 2. Here is action line for weight 2. So angle between R2 and weight 2, 90 degree. So the system now rotate here clockwise. Okay, so what is the value of R2? Okay, here is center here. So here is 30 cm. So mean that here is 20 cm. So from axis rotation to weight 2 here. So distance here is 50 cm. Okay, so mean that R2 equals to 50 cm. Okay, now for another force here, weight 3. So axis rotation here to apply force weight 3 here. So here is action line for weight 3. Okay, so here is here is R3. And angle between R3 and weight 3 here is 90 degree. So R3 from axis rotation to apply force here, weight 3 here. So R3 here equals to 20 cm. So the system here rotate anti-clockwise. So we can substitute the value here. Torque clockwise equals to torque anti-clockwise. So torque clockwise here is for weight 1 and weight 2. So formula here R1 weight 1 sine theta 1 plus R2 weight 2 sine theta 2 equals to R3 weight 3 sine theta 3. So we substitute the value. R1 here is 30 cm in SI unit, so 0.3. Weight 1, okay, mass for rod here is 2 kg, so 2 times 9.81 sine 90 degree plus R2 here is 50 cm, so 0.5 times mass M times 9.81 sine 90 degree equals to R3 here is 20 cm, so 0.2 times 6 kg, 6 times 9.81 sine 90 degree. So we can determine value M, mass M here equals to 1.2 kg.